You're out. You're scanning. Maybe you're paying for a coffee without touching a terminal, or perhaps you're opening an augmented reality experience right off a magazine page. It's just a simple square, black and white dots, but in less than 3 seconds, it instantly transfers complex data to your phone. Have you ever stopped to wonder how? It's not magic, it's brilliant engineering, and in the next few minutes, we're pulling back the curtain on the hidden language within every QR code, revealing the precise anatomy of its data transfer. To understand the transfer, we first have to understand the code itself. Forget calling it an image, it's a densely packed storage device. Look closely. Every code is anchored by 3 larger squares placed in the corners. These are the finder patterns. When your phone's camera sees these 3 anchors, it instantly knows 2 things. I'm looking at a QR code, and critically, this is the orientation. That's the secret to why you can hold your phone at any angle and still get a perfect read. Connecting those 3 corners are thin alternating strips of black and white. The timing patterns. They tell the scanner the exact size of the grid, ensuring it correctly maps out every single dot or module inside. Everything else, that vast, confusing expanse of dots, that's your data. The 3-second journey begins the instant your camera's sensor is flooded with light. It immediately translates the physical code into a massive array of electrical signals, a raw digital grid of pixels. The finder and timing patterns quickly establish the boundaries. Now, the phone moves into the core operation, decoding. Every little black or white square is treated as a single binary bit. White is a 0, black is a 1. Your phone is essentially reading this giant, jumbled stream of ones and zeros, hundreds of them, and organizing them into code words, small digital packets that represent letters, numbers, or commands. This whole process is quicker than a blink, but what if the code is scratched, dirty, or blurry? The system has to be perfect, or the link breaks. That brings us to the true genius of the QR code, its error correction. The code dedicates a significant part of its space, up to 30%, not to the data itself, but to redundancy checks. It uses a mind-bending mathematical concept called Reed-Solomon coding. Imagine you write the word cat, but also write a separate clue that says the second letter is A. Even if you smudge the middle letter of the main word, the clue lets you mathematically reconstruct it. This coding allows the phone to completely fill in and retrieve up to 30% of the data, even if it was physically destroyed. That's why you can still successfully scan a coffee-splattered ticket or a poorly printed coupon. After the decoding, the organizing, and the reconstruction, the phone has one clean, final piece of data. That final piece of data isn't a website or a payment screen, it's a command, usually just a simple URL link. The phone's operating system sees this clean link, recognizes it as a command to open a browser or a specific app, and instantly executes it. That is what happens in the 3 seconds between a flash of light and a connection. A precision dance of geometry, binary code, and sophisticated math, all to get you from a square grid to a fully rendered web page. The next time you scan a QR code, you won't just see black and white dots. You'll see a complex, resilient, and brilliantly designed piece of data transfer technology doing its job perfectly.